So, yeah, I guess we can start. So, welcome to the week 5 problem solving discussion session for this NPTEL course, which is NOC 26C50 Geotechnical Engineering 2 Foundation Engineering. Myself, Rituraj Singh Rawat. I am currently working as a Prime Minister Research Fellow in Department of Earthquake Engineering from IIT Roorkee. This course is currently being tutored by Professor Dilip Kumar Bedia, who is Professor in Department of Civil Engineering from IIT Kharagpur. So those who are joining these sessions for the first time, let me tell you what are these sessions meant for. So here we will basically interact with our learners. We will be discussing some of the important concepts which will be required to solve some of the assignment problem. Along with that, we'll be solving some of the sample questions which will be helpful for you to uh, solve the your that particular big assignment question. We'll be solving some of the doubts related sessions. Apart from that, if you are having any other query related to the course, or let's say if you want to have any guidance from our end, please feel free to discuss. So let's start with the course today. Let's start with our sample questions today. So this is the first question there. So in the geotechnical investigation of the earth dam construction, borehole depth should be at what particular depth? So let's check the answer. So the correct answer is 0.5 times the width of its piece. So in geotechnical investigation of the earth, borehole depth should be at least minimum 0.5 times the width of its base. So let's say this is your particular earthen dam. So let's say this is your width. So this borehole depth sorry sorry should be 0.5 times the b. Moving to the question number 2, the cone penetration test measure the resistance of the soil. So in what terms the CPT basically measures the resistance of the soil? So the correct answer is B, cone resistance. So the CPT measures the resistance of the soil in terms of cone resistance. Question number 3. So the time factor for clay layer is a dimensionless parameter proportional to drainage path, independent of thickness of clay layer, or all of the above. So let's check the answer. Correct answer is a dimensionless parameter. So if we make the time factor, so it's given by pi by 4 multiplied by u square, where u lies in a range of 0 to 60 percentage. And let's say for another case, your time factor is 1.781 minus 0.933 log 10 100 minus u percentage. So for this, usually u is greater than 60 percentage, right? So here u is greater than 60 percentage. So in both the case, we can see the time factor is basically taking input as the degree of consolidation, which is represented by the u, and in both the case, your u takes value in percentage. So basically, since this entity is your dimensionless, so that's why your corresponding TV is also a dimensionless parameter. So time factor for clay layer is a dimensionless parameter. Moving to question number 4, it is a numerical based question. So you are having a sampling tube with cutting edge is used for extracting the sample. If the area ratio of the sampling tube is 15% and the external diameter of the sampling tube at the cutting edge is 80 mm, then the sampling tube thickness at the cutting edge will be. So your area ratio AR is given by dw square minus dc square upon dc square into 100, right? Now your area ratio of the sampling tube is none other than your 50. So dw square upon dc square minus 1 into 100. So that is your first equation. And also it has been given that the external diameter of the sampling tube at the cutting edge is 80 mm. So your so if we check the equation, it's dw by dc square is equals to 1.15, right? So your dc square is none other than your dw square by 1.15. So your dc is your dw by root over 1.15, right? So the sampling tube thickness at the cutting edge will be measured in mm. So it's none other than dw by dc by 2. Now we know your dw and your dc is dw by root of 1.15 by 2. So your dw is 80 mm. So it's 1 by 1 over root over 1.15 by 2. So if we calculate this, so the answer which I am getting it as 2.70. So correct answer is option B. The sampling tube next at the cutting edge will be 2.70. Moving to next set of question number 5 to 6. You are having a 2 meter by 2 meter square footing which was constructed at a depth of 2.5 meters below the ground surface. The water table is at 2.5 meter from the ground level. The footing is subjected to, let's say, 1875 kN, and the total thickness of the clay beneath the sand layer is 4 meter. Yeah, the clay is resting above the hard rock. The load beneath the footing is disturbed in the earth at 1 vertical, 2 horizontal. So gamma W is given to you. Increase in effective stress at the middle of the clay layer due to the application of foundation load is. So you are having a unit weight which is 16 kN per meter cube. Your water table is located at the 2.5 meter depth above the ground surface. Then you are having a 1 meter below your compressible clay is there, which is of a thickness 4 meter. So let's check the answer. So you are having a slope of one vertical, two horizontal, one vertical, two horizontal. So the total depth till here is your 3 meter. So this will be your 6 meter thickness. So this is how your load distribution basically takes place. So since they are asking in the question, like we need to calculate the increase in the effective stress at the middle of the clay layer, right? So your middle of the clay layer is none other than here at your 3 meter, right? So that's how it's coming. So if you see uh, your total thickness from here to here will be your 6 plus 2 plus 6, which is your 14 meter. So your increase in effective stress, so your delta sigma is none other than, since your footing is subject to 1875 kilonewton and your total dimension is 14 by 14, since it's your square footing, so 14 here and 14 in the direction uh, perpendicular to the plane which has been shown. So your delta sigma, if we calculate, so it's your none other than your 9.566 kPa. So your answer is 9.57 kPa. Moving to question number 6. Now we need to calculate what is the total settlement of the footing due to the consolidation. So now we have calculated how much your effective stress is getting increased at the middle of the clay layer. Now you have been asked like how much is the total settlement which is happening in the footing due to the consolidation. So you are having a 2 meter by 2 meter square footing which was constructed at a depth of 2.5 meter below the ground surface. The water table is at 2.5 meter from the ground level. The footing is subjected to, let's say, 1875 kN, and the total thickness of the clay beneath the sand layer is 4 meter. The clay is resting above the hard rock and the load beneath the footing is disturbed in the earth at one vertical, two horizontal. So you need to evaluate how much is the total settlement of the footing due to the consolidation is. So you need to calculate what is the total settlement of the footing. So it's given by SC CCH 1 plus E naught log sigma naught plus delta sigma upon sigma naught, right? So your CC value is given to you, which is none other than 0.16, height of your 1.0, 1 plus 1.25, calculating your sigma naught at the middle of the clay layer. So it's your 3.5 into 16 minus 1 into 9.81 minus 2 into plus 2 into 22 minus 2 into 9.8. So if we calculate this, 3.5 into 16 plus 2 into 22 minus 9.81, also minus 2 into 9.8. So your sigma naught is 70.57, right? Okay, here it is 19.19. Okay, so we need to reevaluate this. So it's your 16 into 2.5 plus 19 into 1 plus 22 into 2 minus, we need to reduce pore water pressure, 1 into 19 sorry 1 into 9.81 minus 2 into 9.81. So your sigma naught is none other than 73.51 kPa. So it's your log sigma naught 73.57 plus your delta sigma, which you have calculated at the back, which is 9.566. So your SC, basically if we calculate this, so it's none other than your 0.0151 meter. If we convert into mm, so it's 15.1 mm. So the correct answer is option C. So yeah, you just need to use the formula for the settlement, which is happening due to a consolidation, and you can directly get the answer. Moving to question number 7. It's Set of question from 7 to 9. You are the consolidation of a newly structure is found to be 6 meter is 7 centimeter, and the thickness of that particular soil layer is 6 meter thick layer. The structure was founded to have settled by 2.15 centimeter in 8 months after the completion of the construction. If the clay layer is underlain by a rock and overlain by a layer of coarse sand, 1 month equals to 30 days. What is the degree of consolidation which occurs in the first 8 months? So the consolidation settlement is given to you, which is 7 centimeter for thickness for thick layer 6 meter. The structure is found to have settled by 2.15 centimeter in 8 months after the completion of the construction. If the clay layer is underlain by a rock and overlain by a layer of coarse sand, 1 month 30 days. What is the degree of consolidation which occurs in the first 8 months? So calculate for the degree of consolidation. So it has been given like for time is equals to 8 months. The settlement which is observed is 2.15 centimeter. So let's say if you are having a clay layer which is of let's say thickness 7 centimeter, and underneath you are having a rock, so definitely there is no seepage of the water will happen here. And then here above you are having a coarse sand. So yeah, here you can observe some seepage. So the degree of consolidation will be calculated as 2.15 upon 7 into 100. So we are talking about u equals to 8 months. So this corresponding answer will be none other than 2.15 divided by 7 answer into 100. It's your 30.71%. So review 8 months is 30.7. So the degree of consolidation occurs in the first 8 months is 30.7%. Moving to question number 8, you have been asked to calculate the coefficient of the consolidation of the soil sample in centimeter square per minute. So let's evaluate the coefficient of the consolidation. So we know what is the degree of the consolidation is u is none other than your 30.7 percentage, right? So since it's less than 60 percentage, so calculate for your time factor will be pi by 4 into u square. So it's your pi by 4 into 30.71 by 100 whole square. So your TV will be 0.3071. So this will be your none other than your 0.0739, right? So calculation of the coefficient of consolidation, so it's your none other than TV s square by t. So if I calculate CV, that's your 0.0739, your thickness of the 6 meter thick layer. So it's your 7 centimeter. And since the seepage is happening only on the one side, so this will be your 0.0 whole square. And then this T is basically happening in 8 months. So if I multiply it by 8 months, so 30, and then I'll convert it into 24 into 60. And also it's a 7 centimeters, so we need to calculate in the centimeter only. So let it be 7 square. Yeah, it's a 6 meter thick layer. Sorry, this is your 6 meter. So this is your 6 meter. I need to convert it to the centimeter. So 100 square. So let's calculate CV. 0.0739 into 6 square into 100 square, answer divided by 8 into 30 into 24 into 60. So your CV is none than your 0.077. So the correct answer is option C. The coefficient of the consolidation of the soil sample in centimeter square per minute is 0.075. Next, you need to calculate the time required for 55% consolidation to occur. So let's say the consolidation settlement of a new structure is founded on a 6 meter thick layer is estimated at 7 centimeter. The structure was founded to have settled by 2.15 centimeter in 8 months after the completion of the construction. If the clay layer is underlain by a rock and the overlain by a layer of coarse sand, 1 month equals to 30 days, then you need to evaluate the time required for the 55% consolidation to occur is. So now you need to find how much time it is required for the 55% consolidation to occur. क्या लेने हैं आप? ये तो पुराना वाला लैंग्वेज। आ जाओ। पढ़ते यार ये लोग बेटे ले जाना, कोई दिक्कत नहीं। हाँ ले जाओ, तुम ले जाना, बताता हूँ। So yeah, now let's calculate the time required for 55% consolidation to occur. So yeah, now calculate the time required for 55% consolidation to occur. So we know CV, your TV is your CVT by H square, and you need to calculate now time. So your H square TV by CV. CV we have already evaluated in the previous part, which is 0.077. Now we're talking about the H, it's 6 square. Only thing is the TV. So it's talking about the 55% consolidation. So 55% consolidation, we know it's a pi by 4 u square. So it's your none other than pi by 4.55 square. So if you see this, so it's your 0.237. So your T is 0.237. So your T, if we calculate, so your T is 110. Okay, it's 0.077 centimeter square per minute. So if you see this, it will be your 100 square. If we convert, okay, the thickness of the soil layer is 6 meter. Okay, so for converting into centimeter, we need to multiply with the 100. So it's 0.237 into 100 square, answer divided by 0.077. So I'm getting something like this. So this is your minute. Now to convert it into days, minutes, 24 hours. So I'm getting around 769.48. So the correct answer is 769 days. Moving to question number 10. So the time required for attaining certain degree of consolidation. We just need to show the relation. We have already seen this. So it's your another CVT by h square. So your t is directly proportional to h square and your t is 1 by c. So your correct answer is B, 1 by c. So in the pile foundation construction, borehole depth should be, what should be a borehole depth in the case of the pile foundation? let's check the answer. So the correct answer is option C. It's 5 meter below the tip. So usually for the pile foundation construction depth, your borehole depth at least should be 5 meter below the pile tip. Moving to question number 12, you are having a sampling tube with a cutting edge is used for extracting the sample. The sampling tube dimension is given. The inner diameter of the cutting is DC. The outer diameter is dW. Inner diameter of the sampling tube is dg, and outer diameter of the sampling tube is dt. So what is the area ratio of the sampling tube? The straightforward formula. So correct answer is dw square minus dc square upon dc square. So usually this is how your sampling tube looks like with cutting edge. And here is your sampling tube having the diameter. So this is your inner diameter of sampling tube with a cutting edge, and then that is your outer diameter. So this is your dw and this is your dc. So dw square minus dc square into 100%. Moving to question number 13, you are having a layer of soft clay which is 5 meter thick which lies under newly constructed structure. The effective stress due to overlying state of the clay layer is 300 kPa, and the new construction increases overburden pressure by 120 kPa. If the compression index of the clay layer is 0.45, natural water content of the clay is 43%, and the specific gravity of the solid is 2.7. If the water table lies at the top surface of the clay, then the expected total consolidation settlement of the clay layer is. You have been given with a layer which is 5 meter thick. It lies under newly constructed structure. The effective stress due to overlying state of the clay layer is 300 kPa and the newly construction increase over. Sigma naught is given to you directly, which is 300 kPa, and delta sigma is given to you, which is 120 kPa. Compression index is given to you, is equals to 0.5, and natural water content is given to you, which is 0.43. Specific gravity is given to you, which is 2.7. If the water table lies, then the expected total consolidation of the clay layer is, and your gamma W is 9.81 kilonewton per meter cube, right? So you need to calculate the total consolidation factor. So HC is your CCH 1 plus E naught log sigma naught plus delta sigma upon sigma naught. So Cc is your 0.45, thickness is given as 5 meter, 1 plus E naught. Okay, compression index is given to you. Okay, then we can directly utilize this for calculating the E. So calculating of the E is Wg by S. You can directly use W is given to you, which is 0.43, G is 2.7, and the degree of saturation which is given to you is 1. So if I calculate E, it's here none other than 1.161. So it's 1.161 log sigma naught, which is 300 kPa, and delta sigma is given to you, which is 120 kPa. So in the sigma naught is effective, so you also need to take account for sigma naught effective overburden pressure. So a log sigma naught. So this will also take account of your overburden with the water. So sigma naught is your 300 plus 2.5 into 9.81. So it's another than 324, right? and your delta sigma is 120, 324.5. Okay, but you need to consider for that particular depth of the soil. So in this case, okay, so that won't work because you need to calculate what is the effective overburden pressure at the 2.5 meter depth at the middle of the clay depth, and for that you need to also get what is the gamma of the soil at that point. For calculation of this, we'll perform here only. So your gamma saturation is your none other than G plus ES gamma W 1 plus E, and this G is basically your 2.7, E S is your none other than is 1.161, and then 1 plus E is your 1.161, gamma W is your 9.81, right? So 2.7 plus 1.161, answer divided by 2.161, answer into 9.81, so that will be your 17.52. So this will be your 17.52 minus 9.81 into 2.5. So this will be your, if I see this, let me calculate again. Log 319.275 plus 300 which is your 0.299. Okay, your delta sigma is 120, it's not 300. So yeah, your correct answer is 144.27. So the correct option is option B. Moving to question number 14, you have been given a lab test of a clear sample of thickness 25 mm, which is lined at the top only, 50% consolidation. Okay, last question of the day. Occur in the minute if the clay layer in the field is 2 meter thick, having drainage at top and bottom, and undergoes 70% degree of, then the time required for the same clay layer is. So it's again the same. You have been given with the two cases. Case A, where your 50% consolidation occur in 11 minutes, and case B, and your 70% consolidation occur in okay, you need to evaluate this. And here you are having one-way drainage, and here you are having two-way drainage. So let's calculate this. So first, in both the cases, we need to evaluate TV 50% and TV 70%. We know for 50% less than 60%, you can directly use the formula, which is P by 4 pi by 4 U 50 by 100 percentage square. And in this case, your formula will go something like this: 1.781 minus 0.933 log 100 minus U percentage. So 1.781 minus 0.933 log 100 minus 70. So if you check this, so to you 0.196, and if you check another case, 0.933 to log 30, 1.781 minus answer. So this is your another than 0.4028. So now they are asking us to time required for the time play layer. So we know it's your CVT by S square, your TV. So if we use this particular relation, your this thing will go T1 by T2 will go something like this: TB1 by H1 square by CV. So CV will be same, both the same. So and then this will be your TV by H2 square. Right. So for this calculation, T1 by T2, your TV1 is your 0.196 and your H1 is 2 meter thickness. At the top only, so you need to take the whole depth itself, 25 square, and then you are having TV2 it's your 0.4028 into your S2, which is your 2 meters. So it's none other than your 2000 square. 0.196 answer divided by 0.4028 answer into 25 divided by 2000 whole square. Okay, you need to calculate the T2. It's 11 minutes. So if you see this, then your T2 will be 0.4028. Okay, sorry. So T1 is 11 minutes. So T2 will be 11 into 0.4028 into 2000 square, answer divided by 0.196 into 25 square, right? And this is in your minute. So answer divided by 24, this is your minutes. 1.196 0.4028 into 2000 square, answer divided by 0.196 into 25 square, answer into 11 minutes, answer divided by, this will be your minutes. So divided by 60 divided by 24 hours. I'm getting something else, I don't know why. 0.4028 into 2000 square, answer divided by 0.196 into 25 square, answer into 11. This is the minutes. So let's convert into the hours, and then let's convert into the days. Okay, here it's your single drainage, so you just need to take that h by 2. Sorry. So 0.196 into 25 square, answer 0.4028 into 1000 square, answer into 11. Yeah, so now T2 will be your, I'm getting 25.11 days. So correct answer will be option C, 25.1. Yeah, that's it for today. Thank you so much for the joining. Those who had not joined, you can watch this video later at the YouTube channel. You can post your queries over there and I'll address the queries there. Let's meet on next Tuesday.